Hi folks, we're going to take a look at an example of finding the equation of a sinusoidal function given a graph. Okay, so here we have our graph, and the first thing we want to look at is where it starts. So I notice that this function here starts from the middle and then goes upwards. So that means that our parent function is going to be sine x. So y equals sine x will be our parent function. Okay. The next thing I need to do is I need to determine the a, b, and k values. Okay, so the first thing I can do easily is determine the max and the min. Okay, that's going to help me determine my amplitude and my axis. So here from the graph, I can see that the max is equal to 11. Okay, and the min is equal to 5. Okay, now with these two, I can now determine what the axis and the amplitude is. So the axis, okay, remember, is that line that goes through the middle. Now I can see here that the axis is going to be at y equals 8, but just so that we can see how to calculate it, because sometimes it's not so easy to see, we remember that the axis is the average between these two, so it's the max plus the min divided by 2. So y equals 11 plus 5 is 16 divided by 2 is 8. So exactly what we expected based on what we saw. Now for the amplitude is the distance between the axis and the max or the min. So we can read it off the graph. From 8 to 11, it looks like the amplitude is 3. But let's calculate it anyways, just so that we get the practice. Okay, so the amplitude is half the distance from the max and min, so it's the max minus the min divided by 2. And here 11 minus 5 is 6, divided by 2 is 3. So exactly as we expected. I would suggest that you always calculate these to be sure. The last thing we have to do is calculate the b value for our equation, okay? Because here let's remind ourselves that the axis will be the k value and the amplitude will be the a value in our equation. Okay, so the last thing we need is the period, okay, which we can calculate from the graph. So take a nice starting point, usually at t equals 0 is a good place to start, and I go along and I see how long it takes to complete one full cycle. So at that point there, I've completed a full cycle, and so I see that that's exactly between 0.02 and 0.06, so the period is 0.04 because I started at 0 and it ended at 0.04. Okay? So once I have the period, I can calculate the b value. The b value is just 360 divided by the period, 0.04. Okay? Now notice here I'm dividing by a very small number, so the result should be a very big number, so don't be surprised by that. So I'll just calculate it. 360 divided by 0.04 gives me 9,000. Okay, so as we suspected, quite a big number. So this is just 9,000. Okay, so now I have all the information I need to write the equation. So y is equal to, so since it's positive sign, the number in front is going to be positive, and that's my amplitude, which is 3. Okay, sine. Now my input here is b times x, so my b was 9,000, so this is 9,000 x, and then plus my axis, which in this case here was 8. Okay. Now, since there's a context to this graph, it's not just y and x. Y and x actually represents something. I should be saying something like where x is, and we see that the x is time in seconds, and here y is the stress. Okay, I should have put is, but we'll just leave it at that. Y is the stress in millipascals, or I guess that's megapascals since it's capital M. Okay, so there you have it. If you have the equation, what you have to find out from the graph are the max, the min, and the period. Okay, once you have the max and the min, you use that to find the a and k values, which are the amplitude and axis, and then you use the period to find the b value. And you look at the starting point to see which parent function you're going to use. Okay, that's it for this one.